Welcome back to the Organic Chemistry playlist. In this episode, we are going over allylic bromination. Remember that allylic is that carbon adjacent, one carbon away from a double bond. So, allylic bromination, I want you to come into this lesson thinking, I want to make this product. If I have that alkene there, I want to make this product here. I want to do allylic bromination. I don't want any other stupid little product in there. I want the allylic bromine to be added. So when you're in the lab one day or you're doing your PhD work and professor says or your instructor says, put a bromine on that carbon, do it now. And you're kind of like, oh, there might be some problems. Let's get into the problems, shall we? So, right here, if we have bromine gas under photochemical conditions, what do you think the product will be? So let's just say the professor says, okay, do an allylic bromination, here's bromine gas, and go outside and shine it under the sun. Go ahead. What's your product gonna be? Well, you might think you'll get allylic bromination, and the most reactive hydrogen species is right there. But you'd be wrong, because remember from chapter 8 of the David Klein's textbook, or if you're following a different one, alkene halogenation. Remember that follows through the mechanism, and hopefully you're starting to be like, oh, I know what's going on. Remember, the bromine ring that forms, and then the bromine nucleophile that broke off comes back in and attacks and forms this here. Is this what your professor wanted you to make? No, it is not what your professor wanted you to make. He or she wanted you to make an allylic bromine, and you made a dihalogenated alkane. No bueno, you don't want that. So how do we do that if we can't do it under the means of which we've learned so far? Well, may I present to you this molecule here, NBS, N-bromosuccinimide. It looks something like this. The cat's not included, I apologize. But it's a simple 5-membered ring, 2 carbonyls, and then we have a nitrogen in there, and then it's attached to a bromine. You're probably looking at this and you're like, ooh, is this some in situ stuff? Yes, it is. It's in situ. In situ, if you don't know yet, it just means it's made in the reaction vessel itself during the reaction. So if we give NBS photochemical conditions, what will we notice? Well, homolytic bond cleavage, and we're going to get a bromine radical. I'm going to omit the conjugate base, I'll say, just like the conjugate form of our NBS here. It's not important, just know we're making bromine radicals. Now what happens? Well, let's say we have our alkene, and we have a bromine radical. Is the bromine radical going to react with the alkene? No, it's not. It's going to react with the hydrogen in the allylic position because it's the most reactive one. It's going to form a radical alkene, and we're also going to get hydrobromic acid. Now these two will come back together, and we're going to see that if we have HBr here, or if we just have a bromine radical, this molecule is going to come back, not this one, that's just a side product. But in the termination step to get our product, what we're going to see is, let's just say we have, well, it's two of them, so it don't really matter where I put it. If I have a radical here, and I have a radical bromine, again made by NBS, we'll see a coupling of the two to eliminate each other to make this here. So, quite simple, right? NBS homolytically cleaves, makes bromine radicals in situ, denies the existence of bromine gas. Now, 2 of the bromine radicals could terminate, and they will. All right, so you do get some bromine gas, but it's not as much as saying, okay, we're just gonna put bromine, we're gonna make a vessel, escape all the oxygen from it, just bromine gas in an inert environment. NBS is just like some bromine gas is formed. You're not going to get an overwhelming amount of your alkene product, and that's very important synthetically, because now we have an allylic alkyl alkene. So quite synthetically useful. That's going to be the end of this episode, though. Hopefully this all makes sense to you. If it did, drop a like. If you have any questions or concerns about what I'm teaching here, drop it in the comments. I am okay with any criticisms or any questions. So thank you guys so much for watching again.